Okay, we just kind of got to the piece about the mean. I know we've all done the mean before because you're all familiar with your grades. You take your grades, you sum all the grades together, and you divide by the number of grades, right? That's sort of the idea, and we get it from a social kind of perspective because we all sort of dealt with that. The mean can also, if you kind of think about it, kind of recognize that the mean is also something we basically call like a balancing point, right, as far as statistics is concerned. And by that, I basically mean, let's say we have a couple of scores. So let me give you an example. Let's say for this, we're going to have the numbers, our n is going to equal 4, which means I'll have 4 numbers on my set. My numbers are 2, 2, 6, and 10. Okay? So this looks fairly easy here. To get the mean, what you would do, and my n is going to be equal to 4, and my sum of x would just be equal to 2 plus 2, 4, plus 6, 10, plus another 10 is 20. So my x bar, or my population, these were all the numbers that I had. This citation here, I haven't gone over it yet, that's mu, which is basically just the average of the numbers that I have in my population. My population's my set. So I'll have the sum of x, which is 20, over 4, you've all done this before, equals 5. All right, so you know how to get to this 5 point, but the way I want you to think about it, this 5 is essentially a balance between all of these numbers. Because if I were to put these numbers out on, let's say, a number line, all right, bear with me. What about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my number line. And I've got 110, right? One weight there. I also have a 6, so I'm going to have a weight here, and I also have 2 weights here. Assume that I have these numbers here, okay? What the mu really tells me is it's kind of finding this point right here. It's the balancing area here. Because if you notice, what we're really doing when we are finding out this piece here is we're finding out the distance from the mean. So if you think about it, if I have x equals 2, let me get this to you. Where x equals 2, if the mean was equal to, let's say, we said it was already 5, all right, so my score, which number am I talking about? I'm talking about 2, 2, 6, and 10. All right, x equals 2, x equals 2, x equals 6, and x equals 10. A little bit clearer. All right, what's the distance from the mean? All right, distance from the mean. All right, we already said that the mean was 5, so the distance of x equals 2 is going to be 3 points from the mean. Same thing here, 3, 1, and 5. Notice that the mean balances basically the differences, okay? This is 3, you've got your 3 points below plus your 3 points below, which is going to be equal to a total of 6 points, right, above the mean, remember? And then I'm also going to have my 1 point above the mean, this 6, and my 5 points above the mean. So if you notice, if the mean is somewhere in here, the sum of these is going to be equal to 6, and the sum of these is going to be equal to 6 as well. Because this is below the mean, this is basically negative 6, and this is 6. One of the interesting things about the mean is that this is negative 3, negative 3. When you sum the distance from the means, you always want to make sure that you get a 0, right? Which is why when we were talking about standard deviation, or how far apart the scores are, we're going to end up, when we're trying to determine the distance from the mean, or the spread of the distance, we're always going to square the numbers so that we can actually figure out what we would call our standard deviation.